So we can continue, yes? Sophia, are you ready?
Yeah.
Um, so we proved this formula, yes, and we can use it. It's very easy. It's very easy. We can only substitute this value if we would like to find present value. Or for example, if we have a 3 and r little 6, so 3 divided by 6%, it will be 50. And in this example, only illustrate using this formula. As 3% UK government balloon will trade at 50 pence per pound in a yield environment of 6%. It is this case, you see. While at 3% yield it's trading at par, it's translated as the nominal. That is, if the face value of the loan is 100, as at this example, and the annual payment 3, it's this. The present value of the loan is 50 when market interest rate are it is this 6% and 100 if 3%. So you see that present value will be changing. It's natural if the environment, economic environment changes, if it 6% or 3%. So you should, for example, find what present value will be if you would like to get $1,000 at the end of the every year. And you know, for example, that percent at the bank, for example, 5%. Yes, you should find this sum, and you in this case you had have a possibility to live only on percent of your income.
I'm sorry, but I have some problems with sound.
Mm-hmm. Do you have any questions about this formula? No, no, it's very useful formula. You see. And the next, annuity on years. What is difference? Difference is that this series of payment finish on only n is C0, C1, C2, and the last payment is Cn. And how we can find present value in this case? Maybe I ask Sophia or maybe three write on this board. Can I ask you?
Yes.
Sophia, да?
Yeah.
Yes. Sophia, maybe I should give you permission.
Yeah.
Mm-hmm. Mm-hmm.
Mm-hmm. Okay.
Please, just minutes. Write, please, first year. First year. First.
Okay.
One, да, or one ST, знаешь, ну, one, maybe better one, yes, exactly. Yes, yes. So we have the first year. At the end of year, we get in our investment. It is PV, present value, right? PV,
Mhm.
PV, and maybe if you can write arrow from left to right, arrow from left to right. Yes. Oh, thank you very much. So, if your initial investment was present value, so at the end of period, it will be PV multiplied, and in the bracket, what it will be, Sophia? PV?
Uh, 1 divided by R.
Yeah,
R.
1 plus R. 1
Ah,
plus
yeah.
R.
Okay.
No, it is formula simple percent O compound, but it is only 1 year, so it's a bracket only 1 plus R. Yes, yes, thank you. And we should give A minus A minus A. Mhm, mhm. Minus A, and that's all. Because in this example, maybe you should write that it is annuity only on 2 years. Maybe write before this row, before
Mhm.
n equals 2, n да, n little, yes, equals 2. So we would like to consider annuity only for n equals 2, for 2 periods. So the first year you put present value. At the end of period, it will be PV multiplied 1 plus R, and the bank give you A capital, A capital. The first year, right? First year or second
Second.
year? The second, second year. At the begin of the second year, we have this sum. Rewrite this sum. PV,
Ой, P.
PV, да, multiplied 1 plus R minus A. Да. And now this arrow from left to right, yes. And at the end of the second year, all this amount will be multiplied by this bracket, yes.
Oh,
Yes.
okay,
Oh,
let it be R plus 1.
да, yes, you are right. You are right. And we should give a capital again. But if n will be 2, it is the end, because now we consider annuity only on 2 years, so it is equals equals 0, 0. It's end, it's the end, it's the end, because the third year we haven't, because n equals only 2. And from this equation, we should find PV, present value. So please, for begin, remove this A to the right side.
Mm-hmm. I'll do it this way. R plus
Yes, you are right.
Okay.
And after that, this A remove.
Okay, equals
It will be, oh, well done,
plus
plus, yes.
AR plus 1 and
No.
no.
No. I would like it is separate. Mhm.
Uh,
Separate. Plus, and it is as proportion.
okay.
Numerator, denominator.
And then we divide by 1 plus
No,
r.
no.
But what?
I don't do this. Please.
Okay.
Uh, if
Mm.
VA move to the right side, it will be plus A. And after that, we divide it by this bracket. This, it is the same, да? Understand? But this divided by this, it is will be this to the square.
Okay. So like this and this. Yeah.
Yes, that's all. Thank you. And it is only for 2 years, annuity for 2 years. But if I ask you to write annuity for an 3 year, it will be, what do you think?
And it will be in such
Yes,
a way.
yes, 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 you are right, and so on. If for n year, it will be plus and so on, and yes. Yes.
Oh wait. For n equals k.
Yeah.
Yeah. Okay.
Yes, you're right. Thank you very much. It will be very useful. So you should this formula. We proved this formula. A sum and 1 divided 1 plus r to the power k, and k from 1 to n. Yes. But what can you say about this? How we can obtain this expression? Who knows?
It's like the sum of geometric progression.
Yes, you are right. If you want, we can now write this at your blackboard.
Okay. I should get a permission from you, but I think that it's clear.
Yes.
Because this 1 over 1 plus r to the k power, it's like it will be less than 1. And so this is the sum of. Oh, okay. No.
No, but it's really easy.
Yeah.
But no, we can now continue the presentation, but at the end we can write this on your blackboard. Yes.
Yeah. Okay.
So we have this formula, and you remember that this input test will be in our input test will be the questions about geometric progression. And really, the sum of geometric progression, we only should to define what is the first term, what is the sum, and try to do. But there are concept future value. It is present value, but this is future value. it is situation when you will be put every year the equal sum, and what is sum will be at the end of periods. For example, at the end of 10 years. The first year and the second year, and every year we put the sum value, some amount of money. So at the end of period, you have this sum, and this sum can be written as sum of geometric progression too. And what is interesting that from this present value we should obtain the present value for perpetuity. This formula R divided by R, A divided by R, little. How we can find this? It is if we find the limit when n tends to infinity. So it will be a case of geometrical progression where, no, to infinity, and it is formula b1 divided by 1 minus q. Yes. So this value, it is 0, and we have only this. Have you any questions? So if you have with you can ask me at the end of lecture. So move to the term structure of interest rates. Interest rate depends on the term or duration of the loan. And now we consider that. And you should distinguish the spot rates and forward rates. Spot rates are capital or are little. It is what announced today, in this moment, and in this case, no present value. It will be found as A divided 1 plus R to the power T. And this ration is called a discount rate. But forward rate quoted today for lending from year U to V. For example, you have some dollars and you would like to put it at the bank account for 3 years. But after 3 years, we would like to take it and put to euro bank account, for example. And how we can today to compute this interest rate, which will be through three years, from 3 years, for example, for 5 years. And the formula for this is very logical, and it's written as 1 plus R sub V to the power V, and this it is product 1 plus R sub U to the power U, and multiplied 1 plus F from U to V, and to the power V minus U. Again, R little in this and in this case, it is spot rates. and we know there today this and this we know, but this is interest rate. It is forward trade. Forward trade. Um, um, Today we don't know this rate, but we can compute this. We can compute this from this formula. Is it clear? No? Sophia, no? Do you understand this formula?
I can't see the point of using the forward rate of finding the forward rates. Could you please give me another example
Yes,
when we can use it?
I can. I can. So let us you use your blackboard.
Okay.
Do you have
But
permission?
no.
Uh-huh. So just a moment. Mhm.
Yeah, okay, so we have 1
Mhm.
plus r okay uv
For example,
v
you can rewrite this formula,
mm-hmm.
and after that, mm, I would like to give you example. For example, R sub V equals ah, for example, V equals 5,
Mm-hmm.
U equals 3,
Mm-hmm.
R V, sub V, R sub
So
V,
r
да, equals 7%,
mm-hmm.
and R sub да, equals no, 2%,
Mm-hmm.
2%. Mhm. And you should to find f from 3 to 5 forward rates f 3 5
So
4 yes.
what does it mean? Um, what is the forward rate?
Forward rate, it is what rate returns bank will be pay you from 3 years to 5 on the
Uh,
third, fourth
so
year. And
this r sub 3, this is the return rate in 3 years from now, yeah?
yes,
This is the
it
return year in
yes,
5 years from now.
yeah, this is percent more than this because in this case I put your money only for 3 years, but in this case I put my money only for 5 years. So it is a percent rate returns more. Oh, it is graphs is very useful. Yeah, yes, but it is from 0 to 5, from 0 to 3. Yes, yes, but we should find from 3 to 5. Yes,
Mm-hmm.
yes, you're right. So we should now
Mm-hmm.
on
Okay.
substitute this. Mhm. Please substitute.
Uh,
One.
okay. So it will be
Maybe
1 point.
one, да, yes.
Pu-
And this 1 point, or comma.
and then,
Yes.
oops. Okay, and then we divide and
Yes, yes, yes.
yeah,
Square.
yeah, I got it. Okay.
Thank you, Sophia.
Thank you.
And summary, the main terms for our today's excursion to finance are return, rate of return, difference, and profit, and logarithmic return, um, cash flow, annuity, perpetuity, and how we can find present value and future value in this cash flow. It is present value analysis, and spot rates and forward rates, and the problem and description of all these terms you can find in a handbook which are on the digital. But no, in this I recommended introduction to mathematical finance, or the book of John Hull. So that's all, and if you have, you can ask any questions, but if you haven't any question, so it's break, and we met on practical exercise. Sophia.
Yeah, okay. I don't have any questions for now.
So maybe just moment. I would like to give print screen. We have 13 participants, and I would like to make print screen. Thank you very much. So, and you see that's all. And 11:40, our next lesson. Yes.
Yeah. Okay.
Yes. Two meetings.